Welcome back. In this part of the chapter, we are going to be discussing a special type of reaction. We're going to be talking about acid-base reactions or neutralization reactions. So you already studied earlier how to name acids. So if I give you the name of an acid, you should be able to write the formula. If I give you the formula, you should be able to write the name. One thing we need to talk about acid is, like I mentioned earlier, then the formula usually begins with a hydrogen, and it could be binary, like this one with only two atoms, or it could be something like this when you have a polyatomic ion involved. But it always begins with hydrogen because by the virtue of being an acid, it's gonna lose that hydrogen in the form of a H plus, or we call that a proton, producing whatever remains. So the main idea is that it loses the hydrogen to something else. So that something else that captures the hydrogen is what we call a base. And the classic example is, let's say that we have hydrochloric acid, which is going to be an aqueous solution. And within that aqueous solution, there's going to be water. And look what happens. See if you can follow what just happened here. We had a hydrogen here, and that hydrogen went with the water. So when the hydrogen left the hydrochloric acid, you ended up with the chloride by itself. So if you notice, the hydrochloric acid reacted with water, and I'm going to show you water like this. We're going to study in about 5 more chapters why water can be drawn like that. And then what happens is that this hydrogen comes in there, producing H3, so 1, 2, and 3. And now it's going to acquire a positive charge, and the Cl is now by itself. So the water accepted the hydrogen. So the substance that takes the hydrogen is what we know as a base. The substance that gives off the hydrogen is what we call an acid. So the reaction that we're going to study in this section is the reaction between acid and bases. Traditionally, most of the reaction between acid and bases, so when you have an acid and it reacts with a base, we call this a neutralization reaction because they neutralize each other. The base stops being a base, the acid stops being an acid, and they become, for example, if you have something like this being aqueous and this being aqueous, if you do what we did before with the total ionic equation and you exchange the ions, you're going to get NaCl, aqueous, and water on this case. So what happened here? You got the H plus, you get the Cl negative, you got the Na plus, and you have your polyatomic ion hydroxide. So the water, the acid, produces the proton goes with the positive goes with the negative, giving you water. Meanwhile, the negative Cl goes with the positive NaCl, Na plus, and it gives you NaCl. So traditionally, neutralization reactions are going to give you an ionic compound and water. That's a typical neutralization reaction. Ionic compounds are also called salts, like NaCl. NaCl, we call it salt, but any ionic compound that comes out of a neutralization reaction is called a salt. So traditionally, neutralization reactions are going to give you a salt and water. There are other types of neutralization reactions that are going to give you gases instead of just water and the salt. So that's what we're going to discuss here. First thing, how do we identify and write acid-base reactions or neutralization reactions, and also learn when they do produce gases. So let's do that with some problems. So, like I told you before, you learn the naming, so now you're gonna have to use that. If you still kind of iffy in that, make sure you go and practice some more. So when hydrochloric acid, and all acids are gonna be aqueous, is a solution, is combined with potassium hydroxide, which is another solution. An acid-base reaction occurs. So the hydrogen goes with one and the base takes something else. So write a balanced molecular equation. So it doesn't give us the product, so you're gonna have to figure out the products. How you gonna do that? The acid is gonna produce H plus, and the other part, whatever that part is, the ionic compound, you can break it down into that and this. So you have to know your polyatomic ions to recognize that. And then the positive goes with the new negative, and the negative goes with the new positive. So that's gonna give you that plus this. And what is gonna be that plus this? That's gonna give you water, which is a liquid, and KCl, positive 1, negative 1, crisscross KCl, which according to the solubility table is aqueous. So you have to use everything now. You gotta be looking at the solubility table to know the phases. So we were able to write the molecular equation, but we're not done yet. So hold on for a second. When hydrochloric acid combined with the potassium hydroxide, an acid-base reaction occurs, and that's how we knew that we had to get the H plus by itself. Write a balance, so let's make sure this is balanced. One hydrogen, actually two hydrogens, two hydrogens, two hydrogens. One chloride, one chloride. One potassium, one potassium, one oxygen, one oxygen. So it's balanced. And what is said that we also need the net ionic equation. So if we want the net ionic equation, we're going to have to go back and break it again. So this is going to be H plus, aqueous, and Cl negative aqueous. So anything that is aqueous, we're going to break it down into the ions. K plus aqueous plus HO or OH, doesn't matter, aqueous, producing anything that is aqueous, we're gonna break it. K plus aqueous plus Cl negative aqueous. And we never break solids or liquid, so we leave the water alone. Now, this is the total ionic, that's not what we want the net ionic. So you're gonna have to eliminate anything that happens on both sides. The H plus, I don't see it on the other side. The Cl negative, I see it. So this and this is an spectator ion, so it doesn't participate of the reaction. The same with the potassium. So the only thing that remains is H plus, aqueous, plus hydroxide, aqueous, producing water, liquid or liquid water, and it's balanced. This is my net ionic equation. Anything that could be written as an ion is written as an ion, and everything in there is used one way or another. So we basically putting together what you learned in chapter 4, 5, and now what you have learned so far up till this moment on chapter 7. So let's see. So now you should be ready to do that one. So same thing, you want to write the molecular equation, balance, and then you're going to do the net ionic. To do the net ionic, you're going to have to do first the total ionic and eliminate whatever repeats on both sides. Do not break apart any liquids or any solids. So now that we know how to do that, can we do something like this? We know that this is an acid-base reaction, so we're looking for my hydrogen because you recognize this as acetate. So this is an ionic polyatomic ion. So that's the H there. So which one can take the H? Well, we're gonna say that this is gonna be calcium 2 plus. This is gonna be OH negative. So this is gonna be H plus, and this is gonna be C2H3O2 negative. So my positive is gonna go with my new negative. So that's gonna give me water, which is a liquid. And then my calcium is gonna go with the acetate, but it's 2 plus and the acetate is 1 negative. So you're gonna have to do C2, H3, O2, but there's 2 of them. And from the solubility table, anything with acetate is always soluble, no exceptions. And that would be how you do that one. Let's do the next one. So for the next one, we're gonna take advantage that we know we're dealing with an acid, so H plus, Br negative, lithium positive, just straight from the periodic table, and I know my polyatomic ions, OH negative. So what are we gonna get? My positive goes with my new negative, giving me liquid water, and my negative goes with my new positive. Secret of life, positive, love, negative. So they always go together, and it's one positive, one negative, so just LiBr. And anything with an alkali metal is always soluble. So there's few things that you can memorize that will save you having to go back and forward to the table that you have been seeing me doing. So anything with an acetate, anything with ammonium, anything with an alkali metal, anything with nitrates, they're always soluble, no exceptions. And that would be what we get on that one. So the last one, once more, we know that we're dealing with an acid. And this acid, sulfuric acid, have 2 hydrogens, but there's always only 1 hydrogen lost at any time. Well, there's something that we haven't covered on this course. We're gonna cover it toward the end. So this is gonna be what we call a strong acid. So these 2 hydrogens are gonna come out. The sulfate is gonna be there. For right now, just believe me, just have faith on me. You will understand later when we cover that chapter. We're doing a whole chapter on acids later. So barium is 2 plus from the periodic table, and because you know there's 2 of these, so it gotta be 2 plus. So when we do that together, my positive goes with my negative, so I get 2 waters. We're keeping track of the coefficients, and my barium goes with my sulfate 2 to 2, so just barium sulfate. And barium sulfate
I don't remember what barium sulfate is, so I gotta use the table for that one. I always forget my sulfates. So let me go to the table here quick, sorry. So my sulfates are always soluble, except when we have barium will be one of them. So this one gives me a solid. So that one will give me barium sulfate, which is gonna be a solid. So never guess. So if you're not sure, just go back to the table. The table is a tool that you should use every time you need to use it. Don't feel bad about using the table. So that will be what we get on that case. Is it balanced? 2 hydrogens here, 2 hydrogens there, that's 4 hydrogens. 1 sulfate, 1 sulfate, 1 barium, and 2 oxygens. So 2 oxygen. All right, so basically what we did before with the swapping of the ions. The positive goes with the negative goes with the positive. So now you're able to do those 3 on your own. And from this part, we move now to see that sometimes the acid-base reaction do not give us salt and water. Sometimes they're gonna give us a gas evolution. And this is something you should have on your notes or memorize it. Every time you react any acid with some type of carbonate, you will always get water. The salt on this case is gonna be that, and carbon dioxide, which is gonna be a gas. So put that pattern on your mind. Every time you react an acid with a compound that contains carbonate, you're gonna get water, CO2, and the salt. Every time you react an acid with a compound that contains sulfite, so sulfite, not sulfate, you're always gonna get the salt, you're gonna get water, and you're gonna get sulfur dioxide, which is also a gas. Anytime you react an acid, and I know those equations are not balanced, I'm just showing you the pattern. Anytime you react an acid with a compound containing sulfide, not sulfite, but sulfite, you're always gonna get the salt and dihydrogen sulfide, which is a gas also. Is there any other one? Yes. Every time any of your reactions produces ammonium hydroxide, this will decompose immediately into water and ammonia. And ammonia is a gas. So gases that you have to be looking for or being able to say where they're coming from: ammonia, sulfur dioxide, dihydrogen sulfide, and carbon dioxide. All these are going to be the gases that you need to find the pattern and know where they're going to come from. So let's apply that to this problem. The first one, we have a carbonate. So here's our carbonate. We have a carbonate and we have an acid. So every time you get a carbonate, you're always gonna get carbon dioxide. Doesn't matter if I put it first or later, as long as I separate it with plus sign. You're gonna get water. And on this case, your salt is gonna be potassium chlorate. So let's see if this is balanced. You have one hydrogen and two over here. So that's gonna have to be a two right there, which gives me two chlorates. So I'm gonna put a two there, which gives me two potassiums and CO3, CO2 and CO3 right there. CO2 plus that oxygen, CO3. So that's how we balance that one. Let's see the next one. So remember, always look for the patterns that I told you. This one has sulfite. So every time you have sulfite reacting with an acid, right? You're gonna get sulfur dioxide, which is a gas. You're gonna get water, and you're gonna get the resulting salt. On this case, lithium acetate. So you gotta know your polyatomics so you can recognize them right away. And anything with an acetate is gonna be soluble, so aqueous. So let's make sure it's balanced now. How many hydrogens we have? We have one and two. We got two hydrogens. How many acetates? We have one. We have one. How many lithiums? We have one. We have one. How many sulfurs? One sulfur. One sulfur. How many oxygens? Three. Two and three. So that one is also balanced. Let's see the next one. So the next one is gonna be ammonium sulfate reacting with calcium hydroxide. This one I don't see an acid per se, but there's an acid there, it's just hiding. So let's do this the way we did the precipitation reactions. This is gonna give me two ammoniums, aqueous, plus one sulfate, aqueous, plus one calcium, aqueous, plus two hydroxides, aqueous. And then we're just gonna take our positive is gonna go with the new negative. So you're gonna get two ammonium hydroxide, right? NH plus and OH negative, so 1 to 1, but there's two of them. In addition to that, and this is gonna be aqueous. And in addition to that, we're gonna get our negative combining with the positive, and we're gonna get calcium sulfate. Crisscross, 2 to 2, and then we simplify. And calcium sulfate, that should be aqueous. And that should be it. However, remember I told you every time you get ammonium hydroxide, it's gonna break immediately into ammonia, and there's two of them, and water. So the answer to this question would be two ammonias plus two water plus calcium sulfate give me is what I get out of this here. So let's double check. We got two nitrogens on the right side, two nitrogens on the left side, 6 hydrogen. So altogether 10 hydrogens, 6 there and 4 there. And on this side, we're gonna have 8 hydrogens plus 2 hydrogens, so 10 hydrogens also. So the hydrogens check out. 1 sulfate, 1 sulfate, 1 calcium, 1 calcium, and 2 oxygens, and 2 oxygens. We do not count the oxygen from the sulfate because we already count them as part of the sulfate. And the last one. So be aware of which ones create the gaseous substances. The last one would be hydrochloric acid reacting with zinc sulfide, which is a solid. So once more, H plus, Cl negative, zinc 2 plus, and sulfur 2 negative. The positive goes with the negative, and that's gonna give me H2S, which is a gas, and I get my zinc chloride by doing crisscross, Cn1, Cl2, and that's gonna be soluble according to the table. So let's balance this. So 2 hydrogens, 2 chlorides, and that will give me that. So once more, be on the lookout for the hydrogen sulfide, which is a gas, carbon dioxide, which is a gas, sulfur dioxide, which is a gas, and ammonia, which is the other gas that you should be looking for. So with that in mind, you're ready for your daily work. And once you do that, we can say that we know how to identify and write equation for neutralization or acid-base reactions. And we know that some of them are gonna give you substances that are gases. And I already told you a few seconds ago which are the substances that you're looking for. With that said, we are done with that part of the chapter. So we got 2 more sections to go and we will be done with this chapter. And then spring break. So see you later, take care. Let me know if you have any questions. Have a great day.